Hello friends, welcome to YouTube channel GD Civil Academy. In this third video lecture, we are going to see simple stress strain problems in type of axial load. So in this, we are going to learn first the relationship, how to calculate the delta L. So this is the first one, change in length due to axial load. Sigma equals to P by A. Sigma stands for stress. Unit is Newton per mm square. P stands for load and divided by area. Okay, so this is the stress. Now what is modulus of elasticity? E, that is stress by strain. Either it is tensile or compressive. Third, it is there E equals to delta L by L, change in length to the original length. It has no unit. Modulus of elasticity unit is Newton per mm square. Now, if you look this relationship, sigma is equals to P by A. So this P by A value will come over here at sigma, and this E means strain delta L by L will come over here, this one. Okay, so they are written P by A divided by delta L by L. So ultimately PL upon delta L into A. So delta L is equals to PL upon A. So how this is very simple. You can easily remember also this relationship, delta L is equals to PL upon A. Now we are going to look the problem. So first problem is a steel column is 120 mm in diameter and 300 mm long. Find the intensity of stress and the strain when it carries an axial compression load of 950 kilonewton. Take E equals to 2 into 10 to the power 5 Newton per mm square. So E value is given, first thing. Second thing, the diameter of the steel column is given. This is the steel column, this is the figure. Axial load means the on the axis of that particular body, particular cylinder or whatever the given example. On that where the CG is lying of that body, the axis is passing, the load is also passing through the same axis of that body. So it is an axial load, means it's a centric load. If it is deviated from the axis, it becomes eccentric load. Okay, so this is the axial load. So how much the axial load? 950 kilonewton. Now load is given, diameter of the steel column is given, length is also given. So what we need to do, 300 mm long it is given. So what we need to do, we need to calculate the intensity of stress and strain when it carries an axial compression load of 950 kilonewton. Okay, so diameter it is there, value of load it is there, E value it is there. So area we are going to calculate by pi by 4 d square. So calculate pi divided by 4 into d, 120 mm square. So 11309.73 mm square will be the area. So what is stress? Stress is nothing but P by A. So simple example, 950 into 10 to the power 3 divided by 11309.73. So 84 Newton per mm square will be the stress value. So it is in Newton per mm square. Definitely the load is going to be compressed over here. Okay, so basically column is in compression member. Okay, so this is why it is in compression. See, the load is acting vertically downwards, so definitely the load which is coming from bottom one, so that will act vertically upward direction. So both loads will compress the column. Okay, so this is nothing but the P by A. So 84 Newton per mm square, it will come compressive stress. So what is stress? E equals to sigma by E. 84 upon 2 into 10 to the power 5, that will come with sigma means stress, E stands for modulus of elasticity. So 84 divided by 2 into 10 to the power 5, so equals to 4.19 into 10 to the power minus 4, that is compressive. So this is a very simple problem that you can easily try at home. Now just a minute. This is the problem number 2. A rod 300 mm long and of diameter 20 mm is subjected to an axial pull of 20 kilonewton and if the modulus of elasticity of the material of the rod is, means E stands for 2 into 10 to the power 5 Newton per mm square, determine stress, strain and elongation of the rod. What is elongation? Delta L. So what is the formula of delta L? Delta L is equals to PL upon E. Very simple. Stress, strain, elongation, they have asked for it. So what we are going to do, first of all, we will write the given data. L stands for 300 mm. This is the figure. This is the figure. 300 mm is the length, 220 kilonewton is the load, 20 mm is the diameter. Now just write down L is equals to 300 mm, D equals to 20 mm, A equals to pi by 4 D square. So area equals to 314.16 mm square. Here in this video I am assuming that you are going to take pen and paper and you are solving this problem. So that's why I told you just calculate or write. Okay. So L equals to 300 mm, D equals to 20 mm, area is equals to pi by 4 D square, that you all know. So what is axial pull? Here is a pull, right? So pull means tensile force, right? So P equals to 20 into 10 to the power 3. E stand for mile steel bar, that is nothing but 2 into 10 to the power 5 Newton per mm square. So this is the given data what we will take, right? So next is, so what we are going to calculate stress and strain. So what is the stress value? Stress is equals to P by A. Yes. So 20 into 10 to the power 3 divided by 314.15. So that is 63.66 Newton per mm square. Stress value, strain value has no unit. Remember this always. Strain has no unit. 63.66 divided by 2 into 10 to the power 5, that is equals to 3.18 into 10 to the power minus 4. Please check the calculations, okay? If you found any difficulty in calculations or answers, please do comment. Elongation equals to delta L is equals to sigma L upon E. So how this comes sigma L upon E? So just check this, okay? So from this relationship also we can write the same. So sigma L upon E is PL upon AE. So P by A, that stands for sigma. So that is nothing but PL upon AE, this one. Okay. So E into L. So sigma by E, that is nothing but E, right? So equals to L. E into L, please check this. Okay. E stands for strain, stands for stress divided by modulus of elasticity. So stress divided by modulus of elasticity. So this comes E. So E stands for strain, strain into length. So 3.18 into 10 to the power minus 4 into 300, that it will be equals to 0.0954 mm. This is nothing but the elongation, that will be in mm because it is a dimension. See what is elongation? Elongation is nothing but deformation, right? So what is the elongation value will be in mm. But remember this strain, it has no unit. And basically what is meant by strain? Change in dimension to the original dimensions. Change in length to the original length. In tensile strain stand for increase in length to the original length. Compressive strain stands for decrease in length to the original length. So you must understand the theory part before solving these simple examples. Very simple example. Next time we will take the problems on different topic. Thank you. If you like this video, please subscribe for the more videos, and also if you have any queries, you can mail me gauri.jadikar909@gmail.com. Thank you so much.